Now let's talk about inverse functions of trig functions. So first, why do we need inverse functions? So imagine the following. If we know that the ratio between the hypotenuse and the opposite of an angle is 2 to 1, then what is the angle theta? Well, we know that sine of theta is opposite over hypotenuse, just because of the SOHCAHTOA. We have that sine of theta is equal to 1/2. If you remember that the special angles are 30, 45, 60, and in there we have the special values of the special angles as 1, 2, 3, right? Square root n over 2. Okay, these are the values, and since this is the same thing as 1/2, we know that 30 degrees is what theta would be. Okay? Now, it is kind of desirable that if you're given any kind of ratio between the lengths, you should be able to find the angle itself. So how do we find the angle from the ratio? So in other words, see, sine of theta, if you're given an angle, you can get the ratio between the lengths by calculating the sine theta, right? So you have opposite of hypotenuse. But what if opposite of hypotenuse is what you're given and you have to know what the angle theta is? That's when you use the inverse function. Well, recall that inverse functions switch input and output, right? So this is your input to the sine function, and this is your output of the sine function. And if you switch them, then that's what the inverse function does. So the sine of inverse would take in the opposite over hypotenuse ratio as the input, and it will give you back what angle that is. And that's a very useful function, because a lot of times not only you want to know the ratio between the lengths when you are given an angle, sometimes you're given the ratio and you want to know the angle. To do that, you need to use the inverse function. So just out of curiosity, if you want to know what this angle is using a calculator, so alright, so if we were to use the calculator to find this angle theta without using this, here's what we would do. We see that sine of theta is 1/2, so that must mean that sine inverse of 1/2 is equal to theta, right? So let's apply that to the calculator. So here's a calculator. I use this thing called Desmos calculator, but if you are taking an exam, you're most likely using a scientific calculator or graphing calculator, something like that, right? So let's assume that you're using a scientific calculator. In that case, you have sine inverse of 1/2, and make sure you're in degree mode so that you get the degree, and the answer is 30 degrees. So you get the angle theta as in 30 degrees by using the inverse function. Okay, now another way to understand the inverse function is like this. An inverse function is something that cancels the function. So if you apply sine inverse both sides, then these two cancel, and then angle theta would be sine inverse of 1/2. So that's another nice way to look at it. Okay. Now, if this was everything, then our life about this inverse function would be very easy. However, there's some added complications, because the angles that we use often sometimes belongs to beyond 90 degrees, or sometimes it could be negative angles. So because of that, now I have to go a little bit deeper into something more complicated. All right. So for now, we accept it as if sine function can have an inverse, but I kind of half lied, because look, here's the sine graph: 360, 180, 90, 270, and the sine graph goes like 0 up, 0 down, and 0 up, right? And it doesn't end there. Sine graph actually continues to the left and continues to the right, and this would be like negative 90 degrees, and so on and so on, okay? And if you recall what you learned when we were doing inverse functions, you kind of noticed something bad going on here. So what's that bad thing? The bad thing is that if you look at the graph, this does not pass the horizontal line test. If you draw a horizontal line here, it passes through the graph several times, right? So it fails the horizontal line test. Okay, and so y equals sine of x graph fails the horizontal line test, which means you're not supposed to have an inverse function of sine. But because of the reason I explained before, we really need the sine function. So what do? Well, we want to change the sine function, or not change, but somewhat take the restriction of the sine function, so that you end up with a part of the function that passes the horizontal line test. And the idea is the following. You take this graph and only take this portion of the graph. In other words, if you take the sine of x, restrict it to negative 90 degrees to positive 90 degrees, then the resulting graph is a graph that looks like this, and any horizontal line that you draw is going to pass the horizontal, it's going to pass the graph only once. So it passes the horizontal line test. So what am I saying here? I'm saying that sine inverse of x is the inverse of not the sine function, but it's the sine of x restricted to negative 90 degrees to positive 90 degrees. Alright, so that's what it means. Now, before we think about the implication of this, let's also think about the domain and range of the sine inverse. Well, we know that when you take the inverse function, the domain and range of the original function switches. So domain becomes the range becomes the domain of this new, the inverse function. So we have to look at the domain and range of the original function. We already know the domain. Domain is this restricted one. And in this domain, the highest value the sine can have is at 90 degrees. And the lowest value the sine can get is negative 1 at negative 90 degrees. So the range is equal to negative 1 to 1. And therefore, this sine x has the domain, so sine inverse of x has the domain as the previous range, and the range equals the previous domain. Okay, now let's think about what this means. Well, it means that when you compose sine inverse and sine, they don't always cancel. If your angle is definitely between, so if this angle is in here, is in this range, then you know that it's going to be this. Okay, so maybe I should write in red. Okay, so warning. Okay, only when theta is between negative 90 degrees to positive 90 degrees. Okay, but you know, in practice, well, sometimes it doesn't work, but in most cases, you're going to be using the sine inverse in this case, this context. Okay, you would know that your angle is between negative 90 to positive 90 degrees, so you're going to be able to just apply the sine inverse to cancel the sine. There will be some exceptions to this rule. I mean, this rule is always true. It doesn't have exceptions, but sometimes your angle won't be between negative 90 to 90 when you apply something called the law of sines that we're going to do later. So when we get there, hopefully you remember this and realize that sometimes sine inverse wouldn't produce the correct angle theta you want because this angle theta lies outside the 90 degrees. It might be bigger than 90 degrees, then because of this warning, sometimes sine inverse doesn't work as you expect. Alright, now you can do the same thing for the cosine and tangent. So let me talk about the cosine graph. The cosine graph is from 0 to 360 degrees, 90 to 70, and then here's 1, then it goes to 0 and goes to negative 1, and then it goes like this and goes up and goes up. All right, and then this still doesn't pass the horizontal line test, but if you choose only from 0 till 180 degrees, that part, in other words, y equals to cosine of x, where your angle is between 0 degrees to 180 degrees, then your cosine inverse does work. So the graph would have only this portion, and since highest is 1 and lowest is negative 1 at 180 degrees, we know that the range is equal to negative 1 to 1. Domain is 0 to 180. And now we can say pretty much the same thing as before, which is cosine inverse of x is the inverse of cosine x with domain restricted to 0 through 180. Okay. And therefore, cosine inverse of x has domain, which is the range of the previous function, and then range would be our previous domain. Now note that in radians this is 0 and pi. Pi is 180 degrees, right? Yeah, I forgot to say that in the previous one. In radians, this angle would be from negative pi over 2 to pi over 2. So for that, that's the one for the sine. Please note that. And for the cosine, cosine inverse, the range would be between 0 to pi or 0 to 180 degrees. Okay. Please make sure that you always know how to put your calculator in the radian mode or degree mode. Sometimes some questions ask for degrees, sometimes they ask for radians. You have to be careful about that. Okay. And then I want to write down the same kind of warning, which is that warning. The cosine inverse function can cancel the cosine function. In other words, they cancel and give you theta only when your theta is in this domain. Theta is between 0 through 180 degrees. Now, in practice, when you use the cosine inverse in geometry, when you have an angle of a triangle, it's always between 0 to 180 degrees. So this limitation actually isn't a limitation. See, The sine function, which has limitation until the 90 degrees, that's actually a very big limitation. Sometimes that does become a problem. But for the cosine inverse, 0 to 180, if you're using this for geometry, it's very handy. It doesn't have much exceptions, so it doesn't have much limitations when to use it. So in many cases, when you use the cosine inverse to solve triangles, then cosine inverse is perfect because it always can be used. Right? So although I wrote down a warning, it's not really a warning. Okay, finally, for the tangent, well, I'm not so sure if you've seen the tangent graph before, but tangent graph goes like this. From negative 90 to positive 90, the graph goes like this. There are vertical asymptotes here, vertical asymptotes, and then the thing repeats afterwards, so that this function here, again, it doesn't pass the horizontal line test, but if you take the tangent graph with the domain restricted to negative 90 degrees to positive 90 degrees, note that I'm not including the endpoints, that's why I'm using the circular parenthesis, circular bracket. We also call this the open bracket because the endpoint's not included. The reason I don't include the endpoints is because at 90 degrees and negative 90 degrees, tangent is not defined. Okay, so we have the tangent x equals to tangent x restricted to the domain negative 90 to 90, and in this case the range is like it goes way down to negative infinity, it goes to up without any bounds, so it's all real numbers from negative infinity to positive infinity. So this will give rise to the tangent inverse. So tangent inverse is the inverse function of this function here, okay? And therefore the tangent inverse has the domain, previous range, and the range as previous domain. Okay, so these are the inverse functions. Let's talk a little bit more about this. Suppose cosine of theta is equal to 2/3. I'll try this one. 2/3. Okay. Then find cosine inverse of 2/3 of sine. Sine of cosine inverse of 2/3. Let's think about this question. This is just checking if you know the definition of what this is. Okay, and I'll say that the theta is between 0 to 90 degrees, just to make things simple. Okay. All right. So let's see. What is cosine inverse of 2/3? Well, the inverse function switches input and output. So this output became the input, and therefore this angle theta will be the output. So this question is really asking for sine of theta when you're given cosine of theta is 2/3. Well, how do you know that? How do you know the value of sine theta when cosine theta is given? Well, here's a nice trick. You draw a triangle, and since SOHCAHTOA, let's say this is angle theta, SOHCAHTOA says cosine is adjacent over hypotenuse, and since that's 2/3, I can put 2 in the adjacent side and 3 in the hypotenuse side. Then what you do is you take the Pythagorean theorems, 3 squared plus 2, no, 3 squared is equal to 2 squared plus this unknown x, I'm going to call it, And if you solve this, you end up with x equals to square root of 5. I'm skipping some steps here, but it should be pretty obvious. Okay, so if you have x equals square root of 5, put that in. And now what is sine of theta? That's opposite. SOHCAHTOA says it's opposite of a hypotenuse, therefore it's square root of 5 over 3. So that's how you do that. Okay. Here's another question that's useful. Find cosine inverse of negative 1/2. Okay, well, cosine inverse of negative 1/2, just call it theta. And again, what does that mean? That means cosine of theta is negative 1/2. So that's the question. Solution. Call it an angle and switch the two around because that's what inverse functions are. So this is what it is. But remember, for the cosine, your angle is between 0 to 180 degrees. So you have to look at the cosine graph from 0 degrees to 180 degrees. So here's 1 goes to 0 and then negative 1. And you have to know when it hits negative 1/2. Well, remember that each quadrant has 3 sticks, and these sticks have nicknames. It's either small, medium, or large. And small, medium, and large, and you have square root over 2. I think of these like coffee mugs on the table, right? And it's easy as 1, 2, 3, right? So you have this, which is 1/2, and that's the small value we're looking for. It's this 1/2, but it's a minus 1, so we're looking for the negative small value, which is this one. Okay, and where's that? That's 30, 45, 50, 60 away from this 90 degrees, so it's 90 degrees plus 30 degrees, which is 120 degrees. And therefore, cosine inverse of negative 1/2 is equal to 120 degrees, because that's what our angle theta is. Alright, so that's how you can compute the cosine inverse without using a calculator.